this video, we're going to go over the periodic table notes. You will find this on, let's see, one second. Pulling up the correct share. You can find these in the packet that I gave you. You can also find them in Teams under Files, Class Materials, Unit 2. It's Unit 2 Notes Atoms. So I like to print them out in different colors, so that way it's color coded, which is really nice. So what we're going to be doing for this section is we're only going to be going over the notes up here. For this particular section of notes, I think if you have some colored pencils, that would be really cool. You could color in, we're going to go over all the different parts of the periodic table and the groups and how they're organized. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. If you have like 8 or 9 different colors, that could be really cool. You can always watch through the video and then go back and color it in. If you don't have colored pencils, that's totally fine. You can just label all the parts. I will say before we really dive into this, the notes we're about to take now are not actually something I expect you to have memorized, and it's not something that I need you to know a lot about. If there's something super important on the periodic table, I would have you put it on this pink one. However, the main one, this is not the kind of thing you should put on here. If you start putting these notes on here, it's going to get super cluttered and it's going to be a hot mess, and you don't want that. So we're just going to do it on here. What we're going to learn about right now is the basics of the periodic table. I want you to have some familiarity about how it's structured and where all of the elements are. You do not have to memorize the elements. You do not have to memorize the elements. You do not have to memorize the elements, unless you really want to for fun, but you do not have to memorize the elements. Anytime we do a test or a quiz, whether it's online or in class, you will always have your periodic table as a resource. So you never have to memorize anything. If you notice, it has all the names of all the elements on here. It would be nice if you could kind of find them kind of quickly, if you didn't have to read through every single one. So, you know, if you're looking for, let's think, silver, it would be kind of cool if you knew that it was somewhere in the middle. Oh, hey, it's right there. All right. If you're searching all over the place. Also, I'm going to tell you the names of some of the sections of the table, which will help you zero it in. So if you say, hey, I'm looking for silver, I'll tell you, oh, it's a transition metal. By the end of this notes, you should have a general idea of where the transition metals are located. You can narrow in, boop, and find silver. So without any further ado, let's dive right in. Okay, I'm going to throw up this PowerPoint. Let's play it. If you notice, it has a yellow background, and that's because it corresponds to your yellow notes. Crazy. All right, so this is the periodic table of the elements. You'll notice that there are 114 elements. This table is actually a little out of date. If you can see right here, these elements actually all have names. So maybe I will post an article or something about those, or we can update those, but they're not super important, honestly. All right, so the way that the periodic table is organized, it's organized in columns, which we call groups, and rows, which we call periods. So each of these groups has a name. The periods are pretty much labeled like 1, 2, 3, 4, 5, 6, 7. So hydrogen is in, hydrogen over here is in period 1, period 2, period 3, period 4, period 5, period 6, period 7. The lanthanide and actinide series are a little funky. They're actually inserted into the table in like a 3-dimensional, like external loop. It's just how it works. The table is organized by, it was originally organized purely by, there's a couple of things, I guess atomic mass, so how big they were, but also, what's the word I'm looking for? Like properties. So the idea is that everything in a group or a family, the columns, have similar properties to each other. So that's what they're all named after. So let's go right through them. So the first one, this group is the alkali metals. Alkali metals are very shiny and soft and react very rapidly in water or even in air. So if you have an alkali metal, it'll almost immediately start oxidizing with the oxygen in the air, turns kind of brown, almost like a rust. Yeah. Okay. The next group are the alkaline earth metals. You'll see it has like magnesium and calcium. Those are pretty important for biological functions. Actually, so are sodium, potassium right next to them. They're sort of similar. They're also brittle, shiny metals, but they react a little bit more slowly. Okay, the next group are the transition metals. So we call them the transition metals because they're sort of in this weird middle section. They're like transitioning from one thing to another. These are most of the most common metals that you've heard of. So iron and copper and zinc and silver and gold and platinum, and a whole bunch of titanium. You may have heard of tungsten before. That's W. That's one of my favorite elements. It's got a great name. Yep, there's platinum, gold, there's mercury. All of those are transition metals. Well, mercury is sort of weird. That's a whole other story. Okay, next section. Okay, this section here is the metalloids. So as we're about to discover, the general categorization of all elements is metals versus non-metals, which is very important and useful. These ones are kind of in the middle. They have some properties like metals, like metals tend to be kind of hard and shiny. They conduct electricity, they conduct heat. And non-metals are kind of the opposite. They're brittle, they're kind of dull, they don't conduct heat or electricity very well. Metalloids are somewhere in between. So we call them metalloids because they're like metals, but not exactly. Okay. Moving on, you end up with the halogens. So halogens are non-metals. Most of these are gases. Fluorine, chlorine are both gases. Bromine is a liquid and iodine is a solid. There's actually very few elements that are liquids at like room temperature, at like normal Earth temperatures. The exceptions are bromine and mercury. Those are pretty much the only liquids. Crazy. These are also extremely reactive with air and most other elements. Fluorine especially is particularly nasty. If you want to make like chlorine gas is was a weapon, a biological weapon in a lot of wars. Fluorine gas is super nasty. It's gross stuff. Those are the halogens. All right. And our last group are the noble gases. So this is things like helium and neon are the ones you're probably most familiar with. They don't react at all with anything, really, almost never. You can get xenon to react with fluorine, and that's about it. They'll never react. They're always gases, and they just kind of do their own thing. They call them noble gases because they don't interact with other things. They're so fancy and noble. They don't want to mix with all those other dirty elements. So that's the idea. All right, last two groups. We call these the lanthanides and actinides. We call them this because they are this weird kind of side group. They are all metals. You'll notice the only ones that you might actually have heard of before are, let's see, where are you? Uranium, plutonium. Plutonium is right there. Americium is actually used in smoke detectors in your house. I'm trying to see if there's any of these other ones you would have actually even heard of. Yeah, not really. We don't really use most of these. Or we actually do, we use some of the lanthanides in like high-end electronic things. A lot of elements as you get bigger are really, really radioactive and often unstable. Many of these elements, especially probably curium and onwards, so that includes all the ones at the bottom here, are made artificially in labs in cyclotrons and have only ever existed for a fraction of a second. Just long enough to discover them so someone could give them a name, and that's it. So that's the lanthanide and actinide series. So this is more a roadmap for you. So anytime you are trying to look for an element, if you ask me, I'll kind of give you an idea based on these. It's good to know, not really something I'm gonna worry about too much or make you memorize. So there we go. All right, let's talk about the thing that you really need to know. Nope, that looks fine. Okay. There is a line, and I'll pull it up on here. This you actually can write on your official periodic table. Okay, you're gonna see on your periodic table, there is this black line. It's already outlined for you on the table that I gave you. This line is really important. It makes the big distinction. The biggest thing that you really do have to know, especially for Unit 3 when we start talking about compounds. This whole side of the periodic table, these are all metals, including the lanthanides and actinides. Hydrogen's kind of weird in that it's sort of a metal and a non-metal simultaneously. It's a little funky. We'll kind of get into it, but there you go. This whole other side of the periodic table is non-metals. So this, I actually want you to write on your table. I just want to check. Okay, we don't want to do that. So I'm going to stop sharing and I'm going to write it on my table just so you can see exactly what I'm talking about. All right, here's my periodic table. Let me grab my pen again. Where did I put it? Ah, here we go. All right, so if you look at the periodic table, you're going to see, again, this black line is already bolded. So what I would do if I were you, like right here or something like it, just write metals. And somewhere over here, write nonmetals. And you can also put a little box around hydrogen and say metal / nonmetal. Right? So if you have this written on your periodic table, it'll be really helpful, so you'll be able to remember those things. So there's that. Let's talk about now, the next thing is what your assignment is. So after you have taken these notes, you can take a picture or send me some documentation. I might end up having a way for you to do that. It's a way just to show me that you've been working, especially if you missed the Zoom meeting. Otherwise, you can get started on the assignment that goes with this. And for this section, we're going to go to our Unit 2 packets. And I want you to work on page 1, which is all of this, and page 2. So this is an activity that is really just designed to help you start to figure out where the elements are and become more familiar with the table. Again, you don't have to memorize anything, but it can be really helpful. So I'm just going to walk you through some of this so that it makes a little bit of sense. So in this first section, the other part of this worksheet I really love is that it helps you understand where all these names came from. There's a whole history behind it, and it's super fascinating. There's a book that I really love. If you ever want to read it, I highly recommend it if you have to read something for like your English class or whatever. It's called The Disappearing Spoon, and it's by Sam Keen. And it's a nonfiction book, but it's extremely readable and entertaining. And it's all about where all these elements' names came from and just history related to them. Super cool. Anyway, this will kind of help you kind of get used to it. So what you're going to do for this first section is look on the periodic table and find elements that are named after countries or places. So pretty straightforward. For B, you've got 4 elements that are named after planets. So see if you can find those. A lot of elements are also named after famous scientists. So there's a list there. I'll tell you a little thing. This is fun. Historically, it's been, if you discover an element, you get to name it. But you have to there's a society of chemists. It's called the it's IUPAC, International something of Chemists. I forgot what it is. But you suggest a name and then they kind of have to approve it to some extent. And most of the time people have named it after other famous scientists or after the place that they were from. There's one guy though, his name was, I forgot his first name off the top of my head. His name is Seaborg. And he discovered like 7 or 8 different elements. It was a whole bunch. He named one of them after himself while he was still alive, which was considered very crass. So there was like, that was a big no-no. It's like, you can name it after places or dead scientists, like Albert Einstein or Alfred Nobel. So there you go. Or Dmitry Mendeleev, who was the first person to who made the first really good version of the periodic table. So anyways, so that's that page. I could ramble on all day, seriously. Okay, these ones are having you connect the name with the symbol. So a lot of elements, it kind of just makes sense. Some of them are kind of funky though. So this will kind of help you just connect the names and symbols. Like carbon is the symbol is C, and that's pretty easy. Iron, you will find, is not I and it's not IR. It's completely different. So watch out for that. All right. This is my favorite section of this whole thing. This is the most useful thing. So a lot of these elements, the symbols come not from their English name, but their original like Latin name. So this is your word, this is your choices. So these are Latin names of elements. And what you're going to do is try to figure out how they match with their English counterparts. So for example, we call copper, that's what we say in English, but the symbol is Cu. So looking at this, how would we translate copper into Latin? Which one of these would probably be would be the best choice? And I think based on the symbol, you should be able to figure it out without too much difficulty. This helps a lot. I think just knowing this made all those symbols make a lot more sense to me. Because you're like, why is copper Cu? That doesn't make any sense. It actually does, if you know Latin. So that is your assignment for today. We'll figure out the rest about turning everything in and getting that done. But that is all that I got for you right now. And I'll see you all in class or in the next video. So thank you all. Catch you later.